we're going to be taking a look at graphing rational parent functions. So we are also going to be identifying key characteristics, including the domain, range, x and y intercepts, asymptotes, locator point, line of symmetry, and holes. So our equation is f of x is equal to 1 over x. So a rational function is an equation that has a fraction. The parent name is rational functions, and the name of the graph is hyperbola. So what we're going to do is we're going to plug in our x coordinates into x in our equation. So we have 1 divided by -3, 1 divided by -2, and 1 divided by -1, we can simplify to -1. 1 divided by 0 is actually undefined. We can't divide by 0. 1 divided by 1 is +1. 1 divided by 2 is 1/2, and 1 divided by 3 is 1/3. So go ahead and take a minute to plot those points. So when you plot those, you'll see that your points are reflections. It's about a 180-degree reflection of each other. And one of the key characteristics of rational functions is that they could have two asymptotes, a vertical and a horizontal. With exponential functions, we learned about a horizontal asymptote, and with log functions, we learned about a vertical asymptote. So rational functions combine them, so you have two. And what an asymptote is the line a graph gets really close to but doesn't actually intersect it. So if we take a look at this first graph, the graph is actually going to be very, very close to the y-axis, but doesn't actually intersect it, so it stays in the first quadrant. Similarly, we draw in the graph for the second quadrant, the third quadrant. So now we can do the same thing in the third quadrant. We know that the x-axis and the y-axis will be our asymptotes and their reflections. So now let's take a look at their characteristics. The domain and range, if we take a look at our graph from left to right, notice that it starts with -infinity and it goes towards +infinity, but remember that asymptote, that vertical asymptote is at 0. So that means x is any value but 0. Any real value except for 0. And similarly with range, we'll notice that from bottom to top, it goes from -infinity to +infinity. It just doesn't have anything here at the x-axis. So we would have y as a solution such that y is not equal to 0. Next, we'll take a look at intercepts. That one's pretty straightforward because if it doesn't intersect an axis, then there are no intercepts for either of them. Now, lines of symmetry, these parts over here that aren't connecting are called branches. So the branches are symmetric to each other. And one branch stays in the first quadrant, so it'd be x is greater than 0 and y is greater than 0. That's one branch. And the other branch is the third quadrant, where x is less than 0 and y is less than 0. We mentioned already that the graph has two asymptotes. The first asymptote is the x-axis and the y-axis. There is no max or min, but the locator points are at 1, 1 and 1, -1, -1. Next thing we're going to take a look at are just some vocab that we started using, but we're just going to specify in words. The rational function, again, is the division of two rational expressions. So that's why it's always a fraction. The hyperbola is the name of the graph for rational functions. And in this next box, we're going to label the definition again. And again, it was a line the graph gets really close to but never intersects. Okay. So the asymptote, there's two of them, the vertical asymptote and the horizontal asymptote. And you're going to talk about this soon when we do transformations. But the vertical asymptote is denoted by when x equals your h value, where your h value determines how much your graph goes to the left and right. And the horizontal asymptote is y equals k, whereas k determines how much your graph goes up and down. So with that being said, we're going to go take a look at the transformations of simple rational functions, and this is the equation for the simple function. A is the number in the numerator, h is in the denominator with x, and k is what is being added or subtracted to that function, to that fraction. So if you recall, we talked about how a, h, and k affect the graph. So h moves the graph from left to right and is called a horizontal translation. The key part to keep in mind is that in the equation it's x minus h. So if you see the minus sign, then that means you keep h as a positive value. If you see x plus h, that means it was a negative number that was filled in. So think of it as using the opposite sign. Okay? K moves the graph up or down and is called a vertical translation. A has two effects. If a is greater than 1, it stretches the graph, so it's a vertical stretch. And if a is between 0 and 1, like a fraction less than 1, then it shrinks the graph. And then finally, when a is negative is when the graph is reflected over the horizontal asymptote. And that's called a vertical reflection, because if this is my horizontal asymptote, my graph is going up and down. So that's vertical. So that is a quick summary of how a, h, and k affect a rational function's equation. As you notice, it's very similar to how a, h, and k affect all the other graphs we looked at this year.